Welcome back, my mysteriously decelerating decision-makers. I'm your quantum superposed spacecraft supervisor, simultaneously solving and creating mysteries across infinite realities. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your project delays like cosmic anomalies requiring decades of scientific investigation. In the grand tradition of unexplained phenomena, today we're diving into a mystery that had physicists scratching their heads for over 30 years. The Pioneer Anomaly, where two of humanity's most reliable spacecraft decided to start dragging their heels on their cosmic commute. Think of it as the ultimate case of employee slowdown, except instead of passive-aggressively taking longer coffee breaks, these spacecraft were violating our fundamental understanding of physics. But before we unravel this cosmic cold case, consider this. In the vast expanse of space, how do we know when something is truly misbehaving versus when our assumptions about proper behavior might be wrong? It's like discovering your most punctual employee is consistently arriving 3 microseconds late. At what point do you question your clock rather than their commitment? Now, gather round the quantum mission control, my trajectory-troubled teammates, for a tale that would make even Newton question his assumptions about motion. I present to you The Consultant Who Killed Momentum, a story about why some forces should remain theoretical, especially if they're being implemented by someone with an MBA in quantum management. In the fluorescent-lit realm of Quantum Dynamics Incorporated, specifically in Project Management Pod C, which existed in a state of perpetual, almost but not quite hitting its targets, Michelle was having what could charitably be called a velocity crisis. It had started, as these things often do, with a square-haired boss materializing in her cubicle with the kind of enthusiasm that usually preceded catastrophe. "Michelle!" he announced, his hair maintaining perfect cubic geometry despite Newton's objections. "I've found the solution to our project slowdown issues. Meet Dr. Isaac Newtonium, our new momentum management consultant." The consultant, a person whose suit seemed to exist in a quantum superposition of charcoal and slightly darker charcoal, nodded gravely. "My proprietary momentum-based management system trademark guarantees consistent project velocity across all phases of implementation." Before Michelle could point out that momentum-based management sounded suspiciously like a physics textbook having an identity crisis, the consultant had already set up shop. His first act was installing what he called a velocity visualization board, a whiteboard covered in equations that looked more like instructions for building a wormhole than a project timeline. The problems began almost immediately. Projects started decelerating for no apparent reason. Tasks that should have taken days stretched into weeks. Even the office coffee machine, normally reliable for at least 6 cups per minute during crunch time, had slowed to a metaphysical drip. "Fascinating," Dr. Newtonium muttered, adding another layer of equations to his board. "According to my calculations, every project is experiencing an identical unexplained deceleration of approximately 8.74 times 10 to the negative 10th meters per second squared." Michelle watched in horror as the consultant proposed increasingly exotic solutions. "Perhaps it's dark matter affecting our project space-time," he declared one day, rearranging equations that now included references to quantum chromodynamics and staff motivation. "Maybe we need to modify our understanding of project gravity," he suggested another time, while trying to explain why the simple act of scheduling a meeting now required tensor calculus. Teams across the company started developing their own theories. IT suggested a cosmic string might be tangled in the network cables. Marketing blamed it on Mercury being in retrograde performance review. The cafeteria staff wondered if they'd accidentally violated conservation of momentum while stirring the soup. As weeks turned into months, Dr. Newtonium's theories grew more elaborate. He proposed testing for quantum project entanglement, suggested measuring for tachyonic anti-telephones, and at one point tried to calculate whether the entire company might be falling into a project management black hole. Only the janitorial staff, led by the quietly observant Maria Gomez, seemed to notice that the consultant's office heater was pointed directly at his precious velocity visualization board, creating a constant thermal current that pushed against his carefully balanced dry erase markers. "Should we tell him?" Maria's colleague asked one evening, watching Dr. Newtonium add another layer of string theory to his calculations. "Nah," Maria replied, emptying his recycling bin full of failed unified project theories. "Some people need to learn about thermal recoil forces the hard way." And so, dear listeners, as we close this chapter on Quantum Dynamics Incorporated's great momentum mystery, remember, sometimes the simplest explanation isn't dark matter, modified gravity, or quantum effects. Sometimes it's just hot air blowing in the wrong direction. Though I should note that Dr. Newtonium eventually published his findings as a grand unified theory of project management, which won several awards and is now required reading at business schools across the multiverse. Maria, meanwhile, quietly adjusted the office heating system and watched as project velocities mysteriously returned to normal, leaving the consultant to ponder yet another unexplained anomaly in his equations. And that brings us to the fascinating science behind why two of humanity's most reliable spacecraft decided to start slacking off on their cosmic commute.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Picture this. It's the early 1970s. NASA launches two spacecraft, Pioneers 10 and 11, on a mission to explore the outer solar system. Everything's going great. They're performing perfectly, sending back data, doing everything asked of them. They're like those colleagues who always submit their reports on time and never miss a meeting, the model employees of the cosmic workplace. But then, something strange starts happening. Both spacecraft begin slowing down. Now, some deceleration is expected. The sun's gravity is like that manager who just can't let go, always trying to pull you back to the office. But this was different. Even after accounting for every known force in the solar system, gravity from planets, pressure from solar radiation, even the gentle push of interplanetary dust, both spacecraft were slowing down more than they should. We're talking about a tiny amount here. A deceleration of approximately 8.74 times 10 to the negative 10th meters per second squared. That's less force than a photon exerts when it hits your computer screen. Less pressure than your colleague Dave applies when he gently suggests maybe we should reschedule that 4:30 p.m. Friday meeting. But in the precise world of spacecraft navigation, even this minuscule discrepancy was enough to set off every alarm bell in NASA's metaphorical kitchen. What followed was decades of head-scratching, theory crafting, and enough peer-reviewed papers to wallpaper the entire Johnson Space Center. Some suggested dark matter. Others proposed modifications to gravity itself. A few brave souls even wondered if we needed to rewrite the laws of physics, which, as any project manager will tell you, is significantly harder than rewriting the employee handbook. When we return from this brief orbital insertion, we'll dive deeper into humanity's 30-year quest to figure out why two of our most reliable spacecraft were apparently developing a case of cosmic cold feet. Welcome back, my mysteriously motivated mission planners. While most of us struggle to track our monthly expense reports, imagine trying to monitor two spacecraft so precisely you can detect a deviation smaller than the width of a human hair divided by the age of the universe. That's exactly what NASA scientists found themselves doing in the late 1980s when they noticed something odd about their most distant employees. Pioneers 10 and 11 were apparently deciding to work remote at a slightly slower pace than physics said they should. Let's start our investigation into the Pioneer Anomaly by understanding exactly what these spacecraft were supposed to be doing when they decided to go off script. Pioneers 10 and 11 launched in 1972 and 1973, respectively, were humanity's first attempts to visit Jupiter and Saturn. Think of them as the corporate trailblazers opening new branch offices in very, very remote locations. These spacecraft were remarkable feats of engineering, spinning like cosmic ballerinas to maintain stability, powered by radioisotope thermoelectric generators, RTGs, and carrying instruments designed to study everything from magnetic fields to cosmic rays. They were like the Swiss Army knives of space exploration, if Swiss Army knives weighed 259 kilograms and cost millions of dollars. Pioneer 10 became the first spacecraft to cross the asteroid belt, first to fly by Jupiter, and first to leave the bounds of our solar system entirely. Pioneer 11 followed a similar path, but took a detour to visit Saturn, like that colleague who always finds a way to add an extra stop to their business trip. But here's where things get interesting. By the late 1980s, as the spacecraft journeyed beyond the outer planets, scientists noticed something odd. Regular tracking measurements showed both Pioneers were slowing down more than expected. Now, tracking interplanetary spacecraft is an incredibly precise business. We can measure changes in velocity down to fractions of a millimeter per second. It's like having a speedometer that can detect the change in your speed when a fly lands on your windshield. The unexplained deceleration was tiny, but consistent. 8.74 times 10 to the negative 10th meters per second squared. To put that in perspective, it's about 1/10 billionth the acceleration you feel in your car when you tap the brakes. But the truly bizarre part? Both spacecraft were experiencing exactly the same deceleration. This wasn't just one Pioneer having a bad day. This was a synchronized slowdown that defied explanation. Scientists started proposing increasingly exotic solutions. Maybe there was a cloud of dark matter creating extra drag. Perhaps our understanding of gravity needed tweaking at large distances. Some even suggested we were seeing evidence of new physics, like discovering your office calculator knows about numbers that shouldn't exist. The mystery deepened when researchers confirmed the anomaly wasn't affecting other spacecraft in quite the same way. The Voyager probes, for instance, didn't show the same consistent deceleration. It was as if these two particular spacecraft had decided to create their own unique interpretation of celestial mechanics. By the early 2000s, the Pioneer Anomaly had become one of physics' most perplexing puzzles. Papers were published, conferences were held, and theoretical physicists sharpened their chalk for epic blackboard battles. The problem attracted everyone from NASA engineers to quantum gravity theorists. all trying to explain why two perfectly good spacecraft had apparently decided to rewrite Newton's laws of motion. The situation was starting to look like our friend Dr. Newtonium's project management theories. The more complex the proposed solutions became, the further we seemed to get from an answer. That is, until a physicist named Slava Turyshev decided to take a different approach entirely. Enter Slava Turyshev, a physicist at NASA's Jet Propulsion Laboratory who decided to tackle the Pioneer Anomaly with a radical approach, looking at all the data. Not just some of the data, not just the interesting bits, but every single scrap of information from the Pioneer's decades-long journey. It was like deciding to audit your company's entire email history to find out why the office printer occasionally makes that weird noise. But there was a problem. Much of the Pioneer data was stored on ancient magnetic tapes, formats so old they made punch cards look cutting edge. Some of the data was scattered across different NASA facilities, filed away in boxes labeled with the administrative equivalent of miscellaneous stuff from that time Dave ordered too many paper clips. Thanks to funding from the Planetary Society, and presumably several pots of coffee, Turyshev and his team embarked on what can only be described as the solar system's most ambitious data recovery project. They managed to salvage more than 30 years of navigational history, which included not just tracking data, but also crucial information about the spacecraft's temperature. Here's where it gets interesting. And by interesting, I mean exactly the kind of simple explanation everyone overlooked while searching for exotic physics. The recovered data showed that the deceleration wasn't constant. It varied slightly over time, like project deadlines during summer vacation season. The smoking gun, the thermal data. Remember those RTGs I mentioned earlier? The nuclear power sources keeping the spacecraft running. They were mounted on long booms extending from the main body of the spacecraft. The heat they generated was being reflected asymmetrically by the Pioneer's large radio dish antennas, creating a tiny but persistent push in one direction. Think of it like this. The spacecraft were essentially experiencing the world's smallest jetpack effect, powered by their own waste heat. The large antenna dishes were acting like cosmic umbrellas, reflecting heat predominantly in one direction. Since photons carry momentum, yes, even heat radiation can push things in space, this created a minuscule but measurable force. In 2012, Turyshev and his colleagues published their findings, definitively showing that this thermal recoil force explained the entire anomaly. No dark matter needed, no modifications to gravity required, not even a single new law of physics. Just good old-fashioned thermodynamics, the kind you might experience if you pointed an office heater at your whiteboard and wondered why your dry erase markers kept moving. The Pioneer Anomaly had actually taught us something profound, but not about exotic physics. It taught us about the danger of assumptions, the importance of complete data, and why sometimes the simplest explanation really is the correct one, even if it's not as exciting as rewriting the laws of physics. Though I suspect somewhere in the multiverse, Dr. Newtonium is still convinced it was all caused by quantum project entanglement. Well, my velocity-verifying voyagers, we've reached the end of another cosmic conundrum. Today we've learned that in the multiverse of mysteries, sometimes the simplest explanation really is the correct one, even if it takes 30 years and several thousand physicists to figure that out. We've discovered that the Pioneer Anomaly, like most unexplained phenomena, wasn't caused by exotic physics or mysterious forces, but by the mundane reality of heat not behaving quite how we expected. Though I must note that thermal recoil forces still sounds more impressive than the radiators pointing the wrong way. The Pioneer mystery teaches us something profound about human nature. In our quest to understand the unexplained, we often reach for complex, revolutionary solutions when the truth might be sitting right in front of us, radiating heat in a slightly awkward direction. Want to dive deeper into the Pioneer Anomaly? Visit us at multiverseemployeehandbook.com, where you'll find fascinating science news and our latest blog series, Lost in Space, a complete history of the Pioneer missions. Learn about everything from their groundbreaking Jupiter flybys to how a team of dedicated scientists and engineers managed to rescue decades of vital data from obsolete storage formats. And somewhere out there, through the vast expanse of space and time, Pioneers 10 and 11 continue their journey into interstellar space, slightly slower than expected, but finally free of humanity's assumptions about their performance metrics. Though I suspect somewhere, in some distant future, an alien civilization is looking at their trajectory and wondering why these Earth artifacts seem to be dragging their heels on their cosmic commute. Remember, in the grand spacecraft of existence, we're all just radiating heat in some direction or another. It's whether we account for it in our calculations that makes all the difference.
Hey, this is Hyde from Pasadena, California. The Multiverse Employee Handbook was created by Rob Corrigan, is edited by Joseph Cooper, and narrated by David from 11 Labs. All science fact-checking is done by Wolf Edmonds. The Employee Handbook staff includes Hugh Mann, Dr. Eric Hale, and Miss Hanley. Please be sure to subscribe to get updates on new episodes.